Yes, you're welcome to my channel. Today we are discussing chemistry. Yes, just as we said, we will start from the very foundation so we understand and know chemistry very well by God's grace. Okay, let's start with the definition of chemistry. What is chemistry? Chemistry is the scientific study of composition, properties, and structure of matter, as well as the changes it undergoes. Yes, I know it's lengthy, we'll bring it down. How do we do it? We say that chemistry is the scientific study of, just like CPX, and write small change. Understand? Yes. Where our C means composition, our P means properties, our S means structure, and our change means the changes it undergoes. Understand? With that, we can say that chemistry is the what? The scientific study of composition, properties, and structure of matter. Matter is the key word. Of matter, as well as the changes it undergoes. You know that virtually everything, most of the things we do is chemistry. How do I mean? And chemistry, as you can see, it has many branches, up to 5. Because of the level we are discussing, we will end up talking about only the organic and inorganic chemistry. So now, when we talk of organic chemistry, what are we talking about? Okay, we are talking about the study of the carbon-based compound. When we begin to study the carbon-based compound, those carbon-based compounds usually have carbon-hydrogen bond. It has carbon-hydrogen bond. We'll do more of it later. This is just to explain the things we are likely to see in chemistry. Understand? Now, in inorganic chemistry, what is it all about? It is the study of compound without carbon-hydrogen bond. Yes, without carbon-hydrogen bond. Understand? You know, this one, carbon-hydrogen bond, we see the main is the basis of life. Do you understand? It's the basis of life. But this one we see mainly outside, also around us, all around us. Example, we have metals. You see metals? We have minerals. And we see salts. Understand? These are inorganic chemistry. Organic chemistry, carbon-based. Inorganic chemistry, not carbon-based. Understand? Okay, having said that, let's forge ahead with matter. What is matter? Yes? What do we say about chemistry? We say that chemistry is the scientific study of composition, properties, structure of matter. So what is matter? Very good. Matter is anything that occupies space and has mass. Anything you can see, you can feel, you can breathe, that has what? You can breathe, that has what? Mass. You can take in space. Example, you see this my hand? Yes. My hand, there's a space on my hand. When I place this marker on my hand, are you seeing that this marker has occupied the space? It has occupied space in my hand. Are you seeing it? So therefore, this marker is a matter. Because this marker occupies a space on my hand, and this marker has particles inside it, this marker is a matter. It has a volume. When we talk of the space, we're talking of volume, understand? And the mass. You can also say that it is density, because density is equals to mass over volume. Understand? Okay, now another good example is, are you seeing this bottle? See this empty bottle. Understand? Of course, there is air inside it. Understand? But anything that can take up the space, it can displace the air and take up the space of this cup. Understand? And has particle inside it is a matter. Example, when we bring our water, are you seeing water? There's water in this sachet. This sachet has water. So when I go home and pour water inside this cup, are you seeing water occupying the space in this cup? Yes. This water, the water inside here, some of them has displaced the air here and occupied the space. So water is a matter. Not only that, you that is watching me, wherever place you are watching, you must be sitting down, or standing up, or lying down, or walking probably. That place you are occupying space and you have particles inside you, so you are a matter. Do you understand it? Okay, having said that, let's go to the branches of matter. Now we have come to the four fundamental states of matter. So this matter we just talked about, you see them in four states. Before, Aristotle and other scientists, ancient scientists, was thinking that the earth is made up of earth, air, water, fire. Have you seen it? And they're not far from the truth. Matter actually exists as solid. When we talk of solid, that means the particles inside that matter are tightly packed. If this is it, if this is particle, are you seeing how packed they are? Are you seeing it? Yes, they are tightly packed, and this way they are made it to be solid, made it to have a definite shape. You can say this is the shape. You can say this is the shape of this thing. Example, this is a solid. You can say the shape is cylinder. Have you seen it? You are seeing the shape. Have you seen it? It occupies volume. It has volume in it. It has volume. It has a definite shape. Are you seeing it? It has volume. Of course, all matters have volume, but it has a definite shape. You can look at it and say, this is circle. That is solid for you. It's only solidified something I can say that it's circle, it's triangle, it's this, it's that. Have you seen it? What's made it to have that shape is because the particles inside it are tightly packed. They are packed, understand? In a fixed position, in a fixed structure. They are packed. They don't move about. There's a small vibration within them, but they are packed. That is solid. Now we'll come to liquid. Liquid is not the same thing. Meanwhile, we have said something about example of solid. Even your book, even your pen, your chair, your cup, they are all solid. Example of solid, okay? Then now we'll come to liquid. You see liquids? Yes, liquid are closely packed, but not tightly packed. They are closely packed, but not tightly packed. Because they are closely packed, they have room to move. It can flow, understand? Mind is a matter, so it will have volume, understand? But it does not have a definite shape. You cannot look at this liquid and say, look at the shape of this liquid. Look at the shape. No, you cannot. Understand? The only thing they do, what makes liquid to have shape, is when it occupies the volume of a definite shape. Understand? When it occupies the volume of another thing. When it takes up the shape of anything you put it into. You can say that a liquid has a shape only when you pour that liquid in a shape, in something that has shape. So it will take up the shape of whatever thing you pour into. Example, because this liquid has been poured into this cup, so it has taken the shape of this cup. Have you seen it? Have you seen it? Very good. Now look at this, another one. Have you seen another liquid? Have you seen it? It has taken the shape of this one. The shape of this one is what? More like a rectangle. This is rectangle. All the sides are not equal, so it's rectangle. So you're taking the shape of this rectangular sachet. Have you seen it? And here, it's taking the shape of cup. That's cylinder. Have you seen it? So that's what we mean by liquid do not have shape, but takes the shape of whatever thing you pour it into. Have you seen it? And mind you, it has volume. It is a matter. Another state of matter is gas. Yikes. We have talked about solid, we've talked about liquid, now is gas. And that liquid, the examples of the liquid, yes, it's water, not talk about it. And the particles for liquid, the particles of liquid, you see, they are closely packed, but they are not tightly packed. So example is our water and our juice. Have you seen it? Yes. We come to gas. In gases, the particles are far apart from each other. They are not closely packed as in liquid or tightly packed. They are not closely packed as in liquid or tightly packed as in solid. They are far apart each other. Another thing, they don't have fixed volume or fixed shape. And somebody will ask me, was it that all matters has volume? Yes, all matters has volume. But the volume of the gas is not fixed. It has volume, but it's not fixed. Why? Because gases are far apart from each other. If you put it in a bigger container, it will fill up, it will expand and fill up that container. If you put it in a smaller container, it will be compressed and be inside that small container. Example, our lighter. Are you seeing this is lighter? There's gas inside it. Are you seeing it? There's gas. Have you seen? They have compressed this gas to inside it. So it now occupy the volume of this. Understand? It expands all through the volume of this. Understand? Now, if you put in a bigger something, are you seeing this one now? This also, gas is inside it. Understand? If you put gas inside this here, gas will fill it. It's empty. That's why I was able to carry it. Understand? Ready to get filled. It will occupy the volume of this too. Understand? So it doesn't have a definite volume. Do you understand it? Yes. So gas will not have a definite volume. If you put a bigger one, it will expand and occupy it. If you put a small one, it gets compressed and be in that small one. Have you seen it? Very good. So having said that, let's go to plasma. For O level, they don't ask plasma. But plasma is also among it. I want to tell my followers so that we'll know more. Yes. So what is plasma? Plasma is the same thing as gas. So yes, it's the same thing as gas. The difference is highly energized. What do I mean? When you bring a normal gas and bombard it with heat, with energy, the temperature goes so high. Understand? It gets so high that it begins to conduct electricity. You know that gas does not conduct electricity? No, it does not. It's neutral, understand? But when you apply enough energy, very high energy, what happens? You tend to tip off electron from the atom of a gas, thereby making it to ionize and conduct electricity. So there is such thing, lightning. I say when there's thunder and lightning, what do you see? Spark of plasma. That lightning is a plasma. The gas which is at the atmosphere has been heated, understand? Has been heated, bombarded with energy. And now it turns to plasma, that is lightning. Which other plasma are we seeing? The sun. Yes. Do you understand? So that's where we stop for now. But before we further ahead, there's a way they used to put it in our examination that we should know. You know, we'll have our gas here. Have you seen it? They can transform to different states. We have solid here, and we have liquid. Have you seen it? When solid changes from solid to liquid, we say it is what? It is melting. It is called melting. Example, that your ice cream you bought that was so solid, if you did not lick it fast, what happens? It melts. Very good. And now, when the liquid should go back to the solid, what happens? We call it freezing. We call it freezing. Yes. When you put it in your freezer, you see that your water has blocked. Very good. And now, when the gas goes to liquid, what do we say? We say it's condensation. We call it what? Condensation. Example, if you go to the kitchen, bring water, put inside your kettle, and do what? And boil it. Have you seen it? As you are boiling it, something will happen. When you open the lid, you will see some water particles on the lid. What happens to it? As you are boiling it, you notice that some steams are going out. That steam that is going out is from liquid to gas, and that is the one that goes like this. That is vaporization. It's called vaporization. As you are boiling your water, understand? If you don't take down your kettle, all of them will evaporate. You don't see them. So as you boil your water, the water will be changing from liquid to gas, and that's called vaporization. But as it's living, because you close your kettle with the kettle lid, if you look at the kettle lid, you see some particles of water. What happens is there are those ones that were not able to escape. So when they met a lower temperature, they come back to liquid. Everything. They come back to liquid. The same thing happens when you put something in the freezer, and when you bring your freezer out, the air around that place you kept that thing water from the freezer will liquefy. Understand? And you see the water vapor that is in the atmosphere. There's water in the atmosphere will condense to form those water particles. You'll be wondering, is it the water that is inside that coke, or is it the water that is inside that food that came out? No, it's the water in the atmosphere that makes a cooler temperature, so it's cool than having it and come back to liquid. Understand? So that is what we call condensation. Okay, now when gas solid moves to gas, it becomes what? Solid, turning to gas without passing through liquid state. Yeah? Yes, we call that one sublimation. We call it what? Sublimation. It has sublimed. Example, you see our mothball. We call it mothball. Mothball. That's naphthalene. For example, from solid to gas is called sublimation. For example, mothball. Sublimation is changing from solid to gas without passing through liquid. Where we see it in our mothball or naphthalene. Naphthalene is what we use to make mothball. Some of us in different places do call mothball camphor, but they're not the same thing. Understand? So that's whitey solid something. I'll put it in the video. You see it? It's mothball. When you leave it, when you come, you not see any water around it. It has gone. Understand it? Another thing is dry ice. Dry ice. What is dry ice? Dry ice. That is carbon oxide that is blocked. When carbon oxide blocked, it's called dry ice. Okay, this dry ice, if you leave it, it will disappear in the air. You will not see liquid. Have you seen it? That's why it is called sublimation. Okay, now from gas to solid is called deposition. It's called deposition or the sublimation, or you call it the sublimation. Understand? Example, that is how snowflake is formed. Yes, no, yes. It's by the position. By the position or the sublimation. Understand? I hope you understand this aspect of chemistry. Okay, for the sake of our exam, we are going to bring in the differences between solid, liquid, and gas. We want to discuss the differences we see amongst solid, liquid, and gas. We have discussed about them. We now understand them. So just put it in a summary or concise form. Now, under solid, we have solid, liquid, gas. Under solid, we have its fixed mass. This is also fixed mass, and that is also fixed mass. So among here, there's no difference. But look at where the difference starts. Particles vibrate and rotate in a fixed point. You say in a fixed point, vibrating in a fixed point like this. In a fixed place. Okay? Then the second one, particles vibrate, rotate, and move about within a restricted space. Are you saying the particles can move? Though it's restricted, but they can move. But it's restricted. Have you seen it? But here, particles are in random motion. moving, going up, piling any space it can see. Are you seeing it? Then now, for solid, it has a fixed shape. You can say this is the shape. But for liquid, you cannot say this is the shape. Neither can you say the same as gas. Two of them takes up the shape of whatever everything they occupy. Okay? How about this one? Volume. This volume have a fixed volume. Fixed volume. This one does not have a fixed volume. I've explained what I mean by fixed volume. I'm just having a volume. Then, incomprehensible. You can't compress a solid. Is the way it is. There's nothing I can do to compress, to shrink this. I can't compress it. Understand? No, I can't. It's not me to compress, I will disfigure it. So I can't compress it. The liquid, you cannot also compress liquid. You cannot put it in liquid, so let me compress it. You cannot compress it. You cannot make it smaller. Understand? Yes. Then, how about gas? We can compress gas. And that's why we use it virtually in many places. You can use it in your car, you can use it as a gas cooker, as a lighter, because we can compress it. The oxygen we use in the hospital, because we can compress the gas oxygen and put in that so that we can compress gas. But other ones are incompressible. But others are incompressible. Others are incompressible, but gas is compressible. You understand? Then how about density? How heavy it is. Very dense. In science, when you talk of dense, we are talking of how heavy that thing is. Solid are very dense, while liquid are less dense. But see, gas, it is the least of the dense substances. It's the least of it. It's not that dense. Have you seen it? I hope you understand it. Do well to practice. Do well to go and find questions and answer. Understand? Thank you. Please like, share, follow, subscribe for more. Bye. Have a blessed day.